In the previous video, we discussed internal rate of return. Here we're going to talk about an issue that arises from IRR and how we can modify the computation to address that issue. The issue with internal rate of return lies in an assumption of the model. When you do a project, you'll get intermediate cash flows. For example, if we have a 4-year project, in year 1, you'll receive some cash flow. What are you going to do with that money the project just generated? Well, you wouldn't just stuff it under a mattress somewhere. No, you would reinvest it into something. Internal rate of return assumes that you will reinvest those intermediate cash flows, and the rate of return that you'll receive on that reinvestment will be the same as the project's rate of return. If you remember from the previous video, we were looking at Project S. This project had cash flows that look like this, and we computed its internal rate of return as 13.11%. When we received that $1,500 cash flow at year 1, the IRR methodology assumes that it's going to be reinvested into something else that has a 13.11% rate of return for the next 3 years. And the $1,200 we receive in the following year, it will also be reinvested at the project's 13.11% IRR. And the same with the $300 we receive in year 3. Why is this an issue? Well, imagine we're evaluating an extraordinary project, a once-in-a-lifetime opportunity that's expected to generate a huge return. We're never going to encounter anything like this again. If that's the case, does it make sense to assume that the cash flows we receive throughout the duration of the project will be reinvested into something which has the same extraordinary return? Probably not. So in comes modified internal rate of return to the rescue. Instead of assuming that the intermediate cash flows will be reinvested at the project's computed IRR, modified internal rate of return allows us to specify our own reinvestment rate. If we identify the project as an extraordinary one, we can use modified internal rate of return to say that the intermediate cash flows will be reinvested in something that has a more typical return. We can break the MIRR computation process into a few steps. Step 1 is to figure out what the reinvested intermediate cash flows will grow to by the time the project is finished. So we'll be computing the future value of the project's cash inflows. The second step will be to compute the present value of the cash outflows. Anytime we spend money, we need to figure out what that is worth today. Finally, you'll set up a time value money problem to solve for the interest rate that connects the future value of the inflows with the present value of the outflows. This interest rate we solve for will be the modified internal rate of return. Let's try it out with Project S. We have our timeline for the project here, and we're going to assume that the reinvestment rate is equal to 10%. What does that mean? That means that once we receive this $1,500 in year 1, we'll reinvest that money and earn 10% per year for the next 3 years. So that $1,500 we receive in year 1 will grow to $1,996 at the end of the project in year 4. The $1,200 we get in year 2 will be reinvested at 10% and grow to $1,452 by year 4. And the $800 we receive in year 3 will be reinvested for 1 year and grow to $880. Adding all those future values together, along with the $300 we'll receive in the final year, gives us a future value of $4628. That means by the time the project is finished, we'll have $4628. The next step is to figure out the present value of cash outflows. That is, money that we spent. For Project S, the only cash outflow we have is the $3,000 spent at time 0. So the present value of that is just $3,000. The final step will be to set up a time value money problem solving for an interest rate, I. We'll set n equal to 4 because this is a 4-year project. PV will be negative $3,000 because we are spending $3,000 to get the project started. And future value will be the $4628 we found earlier. Now think about what we're asking the calculator here. We're saying that if we invested $3,000 into a project for 4 years and ended up with $4628 at the end, what is the implied rate of return? Solving for I, we get 11.45%. That's this project's modified internal rate of return. Now compare that to the 13.11% IRR we computed before. Why is this modified rate smaller than regular IRR? It's because of the reinvestment rate assumption. With regular IRR, we assume that we would get a higher return when we reinvest. And that assumption can artificially inflate the project's rate of return. And it's going to cause us to make poor decisions. By specifying a more reasonable rate, we may be able to get a better picture of the project's actual performance.